The maximum value of the function 40 minus x squared minus y squared subject to the constraint x plus 3y minus 10 is equal to 0 occurs where the gradient of the difference of the function and lambda times the constraint, so the constraint is actually an equation, some algebraic expression equal to 0. When I say the constraint, I mean the left-hand side of the equation, some expression is equal to 0. Okay, so where is this gradient equal to 0? Well, I take that single equation. It's equivalent to this system of three equations because the derivative with respect to x of that expression is negative 2x plus lambda. See, x term there, x term there. I think I've done everything all right. Derivative with respect to y, negative 2y plus 3 times lambda. And derivative with respect to lambda simply gives the left-hand side of the constraint, or the entirety of the entire constraint equation will always be the derivative with respect to lambda part. Now, that system of equations, I rearrange it to get lambda by itself so that I could substitute that expression for lambda into the second equation. I put in 2x for lambda to get 6 times x right there, so 3 times 2 times x, and then I put the x first and the y second, minus 2y second equal to 0, and then I'm going to take the second equation, or the third rather, equation here, multiply it by 6 so that the coefficient on x there and there is the same. That 3, oh man, I see a mistake I made. I multiplied this equation by 6 to give me an 18y, but on the right hand side I ought to have had multiplied by 6, so that should be a 60. Oops, wrong color pen. 60. Okay. And then, from there, I can take this expression right here that can be rearranged to give me, oh, I'm sorry, not rearranged, but these two equations. Let's see, I'm going to replace the third equation with a third equation minus the second, so I'll have 6x minus 6x is 0x, despite my ugly 0, that's what I intended to write. And 18y minus negative 2y, that'll be 20y's, and then I have 60 minus 0, so I should have a 6 right there. And then I have 20y is equal to 60, and that actually says that y is not 1/2, but 1/3. So there's a mistake. And then with y being 1/3, I put that back into this equation. And so I made a mistake. I used to have 1/2, but now if y is 1/3, then right there I need to put in a negative 2/3. Okay, let's see. And I've simply copied this equation. So we have y is 1/3, x is 2/3 divided by 6, which is 1/9. Okay, 1/9 there. And then x goes into this equation for lambda, and 2/9. Yeah, okay. Which has solution, let's see. Of course, I'm going to have the order x, y, lambda, and x should be 1/9, y 1/3, and lambda 2/9. Okay, so that's looking nice and ugly because of all of my mistakes. A point where the value of the function is 4 minus x squared, but x should be 9, and minus y squared is 1/3 squared. Okay. And I decline to calculate that that arithmetic expression, simplify it. Okay, I am taking a look now. I want to draw this. The maximum of this function, subject to this constraint, I'm drawing the constraint here. Okay, so that is a constraint in the xy plane, right? A solution set to this equation is a collection of points in the xy plane, and you guys know that it forms a line because that is a linear equation. And so I am restricting the domain of this function of two variables to simply that line. Now let me draw the graph of this function 49 minus x squared minus y squared, if its domain were all real numbers, its graph would be, let's see, that would be a, imagining the equation z is equal to 49 minus x squared minus y squared, that would be a paraboloid, elliptic paraboloid, but with the eccentricities the same in both directions. So 49 minus x squared minus y squared, let's see, that will start way up here at 49. How do I do this? 1, 2, 3, 4, 5. Say that's 50 there. And that's 49. And let's see. If I stay in the x is 0 plane and allow y to go over to 49, let's see, what squared is 49? Is it 7 times 7 is 49? So this will go all the way over to 7. 1, 2, 3, let me put in a few more tick marks there. 4, 5, 6, 7. So this graph would go all the way over to 7 there. At 7 I'd get 0, right? 49 minus 0 squared minus 7 squared would be 0. And then I need to draw that symmetrically in the other direction, about like that. And then similarly in the x direction where y is 0, I need to go at 1, 2, 3, 4, 5, 6, 7 to about there. And back I need to do about the same thing. Okay, and then it seems to me that I ought to continue this curve downward, and the place where I am looking, okay, that is to say I am trying to find the maximum of this function, and that is the highest point on the green surface above the blue line. Okay, the highest point on the green surface above the blue line, that, let's see, over here, directly above that blue point would be that, wouldn't it? And then directly below this blue point would be something way down here on this green line, and so I can't quite draw him. How about if I do something over here? Right, directly below that is, say, that. So I'm thinking this is straight up to the blue line. Okay, and then say over here. Now I'm thinking that this green point right here is below that blue point. That is a negative value, and this is a positive value for the function. The function seems to, I'm not sure if I should do this in red or in green, but the function seems to, right, there is a point at which this blue line here will intersect the green surface. So let me figure out approximately where that is. I get the feeling it would be about there. And no, that's no good because now these three things are in line. I think I'm feeling a line about like this that is curved. Comes down the other side. Probably not a particularly good picture for you guys, right? But directly above that blue line, part of the green surface is this line that I've done in red. Right, so it's in red and green. It's part of the domain.